So, hello all, welcome to the tutorial on rocket propulsion. So today we are planning what I am planning is to do some numericals on electric propulsion, followed by some numericals on nuclear propulsion, and I'll show you some video where US has tried to make a nuclear rocket. So there's a testing video which I will show you. So next is we'll be dealing with the solar cell, and finally we'll review all the things that we have used so far, and we'll try to design a liquid rocket engine from the scratch. So yeah, so this is all for today. Okay, so let us start with the magnetoplasma rocket. So we have variable specific impulse magnetoplasma rocket, so which is known as Vasimir, and it was conceptualized by NASA in 1977. So we okay, in this case we have a magnetic field of strength 0.5 Tesla, which acts normal to the direction of the velocity. So we have a magnetic field which is normal to the direction of the velocity. Uh, and we also have the plasma which is charged at 1.5 coulomb. The charge, so we have to find the velocity u, and if it is given that the thrust of the rocket is 0.22 Newton. So to calculate this, let us write this. So the magnetic field strength. So we have magnetic field strength, uh, which is denoted by B as 0.03 Tesla, and the plasma has a charge Q which is 1.5 coulomb. The thrust that it generates is given as 0.22 Newton. So we can calculate what is the thrust, where the thrust equation is given as Q V J into B. So we have 0.22, and Q is given as 1.5 Vj, and B is given as 0.03. So with this, Vj can be calculated as 4.88 meters per second. Okay. So yeah, so let us move to another problem. So yeah, so we have a mass of, okay, we have charged particles which has a mass of 250 microgram, and it is used in electric propulsion system where the electric field strength E is given as 400 volts per mm. So we have two charged plates. Yeah, so the electric field strength E between these plates is given as 400 volts per mm, and the charged mass is 250 micrograms. Now yeah, the distance between this grid X is given as 2.5 mm. Okay, yeah, so we have to find the potential difference across this plate. So the potential difference is E is given as V by D, where E is given in the problem, which is 400, and the distance between the plate is given as 2.5 mm. So the voltage between the plates can be calculated, which will be around 1000 volts. Yeah. So to then we have to calculate the velocity, which is at the exit, with which the mass will be escaping out. Okay. To calculate this, we have uh, so we equate the kinetic energy to the work done on the mass. So with this we can calculate what is the value for this velocity. So when you do that, you can calculate the velocity of the jet, which will come out to be 9797.9 meters per second. Okay, so the next part is, if the mass of the charge is uh, okay, so is given as 1.25. Okay, the mass flow rate is given. So the mass flow rate is given as um, into 10 to the power minus 6 kgs per second. So we have to find what is the current that will be flowing inside the grid. To calculate this, we have m dot can be calculated as dm by dt. So the time interval is basic can be calculated by the charge and the current. So this is m by q. So the current can be calculated uh, as 31.25 into 10 to the power minus 6, and it is given that the charge on the plate charges on the mass is 12 coulombs. So divided by 12 into yeah uh, okay, so it will be, sorry, so yeah, so it will be 31.25 into 10 to the power minus 6 into 12 divided by 2.5 into 10 to the power minus 4. So it will give you the current as 1.5 amperes. So now to calculate the thrust is just given as m dot vj. We have m dot, which is 31.25 into 10 to the power minus 6 kgs per second, and the velocity is 9797.9, so which gives you a thrust of 0.306 newtons. Yeah. So any doubts on this? Any doubts any in any other problem? Okay, so let us move ahead. So we have a nuclear thermal rocket. So the energy that is being generated by the nuclear fission reaction is used to heat the hydrogen, and then the hydrogen is so we have a so in a nuclear rocket engine we have a CD nozzle, and inside this we have the uranium rods. So so the due to the fission process, the rods will heat up. So the temperature of the rod will heat up, and when the hydrogen passes through this, the hydrogen also due to the conduction and the convection process, the hydrogen also gets heated up, and which increases the pressure, and yeah, we can use this heated hydrogen to expand to the nozzle, and we can generate thrust. So there is a video which I would like to show you. This is by NASA, and yeah. So I hope. I hope you can hear the sound, right? Yeah. Okay, I can't. Yeah, yeah. So, the principle. Maybe I'll jump on to the principle. What? So then, as we compare the nuclear rockets, so it has a higher ISP value, which is somewhere about 900 seconds. So maybe I'll jump on to that part. So maybe.
So maybe
Uh, okay, so maybe I'll share this video with you all. So yeah.
yeah.
So
So
okay, so I'll
okay, so
share
I'll
this
share
video with
this
you
video
all.
with you all.
So maybe
So
you can
maybe
see
you
this
can see
video.
this
It
video.
is related to
It is
this
related to
nuclear
this
rocket
nuclear rocket
propulsion.
propulsion.
Okay, so let
Okay,
us
so
move to
let us
this
move to
nuclear
this
rocket
nuclear
engine.
rocket engine.
Calculation of
Calculation of
for nuclear
for
rocket
nuclear
engine.
rocket engine.
We have a
We
hydrogen
have a
gas that is
hydrogen
being
gas that
heated
is
by a
being
nuclear
heated by a
thermal
nuclear
power
thermal
rocket.
power rocket.
So
So
yeah, so the
yeah,
heat
so
that
the
is
heat that
generated
is
in a
generated in
fusion
a
reactor
fusion reactor
is
is
in
in
equilibrium
equilibrium
condition.
condition
Uh,
uh,
is given
is
as
given
2
as 2
megawatt.
megawatt.
The nuclear
The
energy
nuclear
is then
energy is
converted to
then
kinetic
converted to
energy
kinetic
of the jet,
energy of the jet,
which is
which
having a
is having a
velocity of
velocity of
400
400
meters per
meters
second.
per second.
So,
So
okay, so
okay, so it
determine
is to
what is the
determine what is
specific
the
impulse of
specific
the
impulse
rocket
of the rocket
uh,
uh,
for this
for
case.
this case.
So first of
So
all,
first of
let us
all, let us
calculate.
calculate.
Okay,
Okay,
so the
so the
ISP.
ISP.
So
So
ISP will
ISP
be
will be
equal to
equal to
400.
400.
It- okay,
Okay,
so it will be
so it will
equal
be
to
equal to
400
400
Newton
Newton
seconds
seconds
per kg.
per kg.
Uh,
Uh,
okay,
okay,
so
so
next
so
is we
next
have to
is we have to
calculate
calculate
the
the
uh,
uh,
if the entire
if the
energy is
entire energy
converted
is
into
converted
the
into the
kinetic energy
kinetic
of the
energy
jet.
of the
So
jet.
we have to
So we have to
calculate what is
calculate
the
what is the
hydrogen
hydrogen
in kgs per
in
second
kgs
that
per
is
second that
required
is required
uh,
uh,
to
to
generate a power
generate
of
a power of 2
megawatt.
megawatt.
So
So
yeah, so the
yeah, so the
power that is
power that is
so
so
okay, so we
okay,
have to
so we
calculate
have to
what is the
calculate
mass flow
what is
rate
the
of
mass flow rate of
hydrogen.
hydrogen.
So
So mass
all the mass,
all
the energy that
the
is
energy that
getting
is getting
generated will
generated
be
will
converted
be
into
converted into the
kinetic energy.
kinetic energy.
So we can
So we can
equate this
equate this
value.
value.
So with
So with
this,
this
we
we
will
will
get
get
uh,
um,
okay.
okay,
So
so
we can
we can
calculate
calculate
what
what
is
is
the
the
mass flow
mass flow
rate,
rate,
which
which
will
will
be
be
equal to
equal to
the
the
which is
which is
just
just
0.25
0.25
kgs per
kgs per
second.
second.
Okay,
Okay,
so now
so
we
now
have
we
to
have to
calculate what
calculate
is
what
the
is the
thrust
thrust
that
that
is
is
developed,
developed,
which will
which
be
will be
equal
equal
to
to
the
the
m
m
dot
dot
into
into
vj.
Vj.
So
So
which
which
is
is
equal
equal
to
to
1000
1000
newtons.
newtons.
Okay,
Okay,
so
so
again we
again we
have
have
another
another
problem
problem
on
on
electric
electric
propulsion.
propulsion.
uh,
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 so
so
we
we
have a
have a
space
space
capsule
capsule
which is
which is
propelled in
propelled
a
in a
deep
deep
space
space
by
by
electric
electric
powers,
power uh,
and
and
which is
which is
supplied by
supplied
a
by a
nuclear
nuclear
power
power
plant.
plant.
So
So
yeah,
yeah,
so the
so the
nuclear
nuclear
power
power
plant
plant
works on a
works on a
principle of
principle of
radioactive
radioactive
isotope
isotope
decay.
decay.
The
The
mission
mission
in
in
deep
deep
space
space
calls for
calls
a
for a
increment
increment
velocity
velocity
delta v
delta
is
v is
required for
required
a
for a
particular
particular
mission,
mission,
which is
which is
equal to
equal to
5.2
5.2
kilometers per
kilometers per
second.
second.
uh,
Um,
and
and
it should
it
be
should be
provided
provided
in
in
70
70
days
days
by
by
continuous
continuous
operation.
operation.
The
The
specific
specific
mass
mass
of
of
system
system comprises
comprising the
comprising the
space
space
capsule,
capsule,
power
power
plant,
plant,
electric
electric
power
power as
electric
electric
power
power
processing
processing
unit,
unit,
and
and
rocket
rocket
is
is
90
90
kgs
kgs
per
per
kilowatt.
kilowatt.
So
So
we are assuming
assuming
the
the
efficiency
efficiency
and the
and the
jet
jet
velocity of
velocity
the
of the
rocket
rocket
is
is
85%
85%
and
and
6500
6,500
meters per
meters per
second.
second.
So we
So we
have to
have to
calculate what
calculate
is the
what is the
payload
payload
ratio,
ratio,
which is
which is
expressed in
expressed
two
in two
decimal
decimal
places,
places,
which
which
has to
has
be
to be
expressed in
expressed
two
in two
decimal
decimal
places.
places.
Okay.
Okay.
To
To
calculate
calculate
this, let
this, let
us
us
write
write
what
what
all
all
values we
values we
have.
have.
So
So
delta
delta
2 for
2
a
for a
particular
particular
mission
mission
is
is
5.2
5.2
kilometers per
kilometers per
second,
second,
and the
and the
efficiency
efficiency
of
of
the
the
okay,
okay,
so
so
efficiency of
efficiency
the
of the
electric
electric
rocket is
rocket is
0.85,
0.85,
and
and
the
the
time
time
duration
duration
is
is
70
70
days.
days.
Let us
Let us
calculate
calculate
this
this
thing
thing
into
into
the
the
seconds.
seconds.
So
So
we
we
have
have, so
70
70
into
into
24
24
into
into
36
36
double
double
zero
zero
seconds.
seconds.
Okay,
Okay,
so
so
now
now
we
we
have to
have to
calculate
calculate
what is
what
the
is the
payload
payload
ratio.
ratio.
Okay,
Okay,
for
for
electric
electric
rocket,
rocket,
the
the
payload
payload
ratio
ratio
is
is
given
given
as
as
mu
mu
by
by
mi,
mi,
which is
which is
equal to
equal to
1
1
by
by
uh,
uh,
psi
psi
vj
Vj
square
square
by
by
2
2
efficiency
efficiency
delta
delta
V
V
by
by
Vj
Vj
minus
minus
x
x
Vj
Vj
square
square
2
2
eta
eta
t.
t.
Okay,
Okay.
so
So
right,
right.
so
So
the
the
electric
electric
processing,
processing.
okay,
Okay.
the
The
specific
specific
mass of
mass
the
of the
rocket
rocket
uh, is
is
given
given
as
as
90
90
kgs per
kgs per
kilowatt.
kilowatt.
So the
So the
psi
psi
is
is
given
given
as
as
90
90
kgs
kgs
per
per
kilowatt.
kilowatt.
So let
So
us
let us
substitute
substitute
this
this
value
value
and
and
calculate
calculate
what is
what
this
is this
payload
payload
ratio.
ratio.
So
So
okay,
okay,
so the
so the
payload
payload
ratio
ratio
uh,
um,
can be
can be
calculated
calculated
if you
if you
substitute
substitute
this
this
1
1
by
by
90.
90.
Vj
Vj
is
is
given
given
as
as
6500
6500
and
and
efficiency is
efficiency is
0.85.
0.85.
The
The
delta V
delta V
for a
for a
particular
particular
mission
mission
is
is 5 to
5200
double zero
meters per
meters per
second,
second,
and
and
the
the
exit
exit
velocity
velocity
is
is 6500.
6500. Again,
Again,
the
the
psi
psi
is
is
90,
90,
Vj
Vj
is
is
6500
6500
square
square
2
2
into
into
0
0
point.
point.
Uh,
Uh,
okay,
okay,
so
so
85.
85.
Okay,
Okay,
so
so
let us
let us
compute this
compute this
value.
value.
We'll
We'll
get
get
the
the
value
value
as
as
uh,
uh,
mu
mu
by
by
mi,
mi,
which will
which will
come
come
out to
out
be
to be
0.265.
0.265.
Okay,
Okay,
so
so
okay,
okay,
so let
so let
us.
us.
I
I
hope
hope
this is
this is
clear,
clear,
right?
right?
Let us
Let us
move to
move to
another
another
problem on
problem on
solar
solar
sail.
sail.
So
So
where
where
so
so
we
we
have a
have a
solar
solar
sail.
sail.
So
So
we
we
have
have
the
the
rays that
rays
are
that are
coming to
coming to
the
the
through the
through the
sun,
sun,
and they
and
are
they are
hitting
hitting
onto
onto
this
this
solar
solar
sail.
sail.
So
So this
these
these
photons
photons
that are
that are
coming,
coming,
they
they
have
have
some
some
momentum
momentum
with
with
them.
them.
So
So
when they
when they
hit the
hit the
surface,
surface, there is a change.
there is a
There is a
change in
change
the
in the
momentum of
momentum
these
of these
photons,
photons,
and a
and a
net
net
uh,
um,
force
force
is
is
experienced
experienced
by
by
this
this
solar
solar
sail.
sail.
So
So
okay,
okay,
so
so
we
we
have a
have a
solar
solar
sail.
sail.
The
The
problem
problem
is
is
as
as
follows.
follows.
So the
So the
solar
solar
sail,
sail,
we
we
have a
have a
solar
solar
sail
sail
powered,
powered,
which is
which is
uh,
uh,
that
that
powers
powers
a
a
spacecraft,
spacecraft,
and
and
the
the
photon that
photon
are
that are
coming through
coming
the
through the
sun.
sun,
The
the
light
light
is
is
okay. It
it
composed
composed
of
of
electromagnetic
electromagnetic
radiation
radiation
that
that
exerts a
exerts a
force on
force
the
on the
object.
object.
So
So
okay,
okay,
so
so
yeah, the
yeah, the
energy
energy
yeah, is
is
given
given
as E
as
is
E
equal
is
to
equal to
h
h
nu.
nu.
Now we
Now
have
we
to
have to
calculate
calculate
the
the
pressure on
pressure
the
on the
surface of
surface of
this
this
uh,
uh,
solar
solar
sail.
sail.
So the
So the
pressure
pressure
is
is
given
given
by
by
2 I
2 I
by
by
c.
c.
So
So
where
where
P
P
is
is
thrust
thrust
by
by
area
area
of
of
this
this
solid
solid
surface.
surface.
Okay.
Okay.
Uh,
Uh,
then
then
so
so
yeah.
yeah.
So I
So I
is
is
the
the
radiation
radiation
intensity.
intensity.
C
C
is
is
the
the
speed of
speed of
light.
light.
Okay,
Okay.
so if
So
you
if you
substitute,
substitute,
okay,
okay,
let us
let us
calculate
calculate
what
what
is
is
I for
I for
this.
this.
So in
So
the
in the
problem, it
problem,
is
it is
given
given
as
as
the
the
intensity
intensity
in the
in the
Dave
deep
space
space
is
is
given as
given as
200
200
watt
watt
per
per
meter
meter
square.
square.
Okay,
Okay.
so
So
if we
if you
substitute
substitute
this
this
value,
value,
uh,
uh,
we
we
will
will
get
get
2
2
by
by
2000
2000
3
3
into 10
into
to
10
the
to the
power
power
8.
8.
So
So
the
the
pressure
pressure
will
will
come
come
out to
out to
be
be
0.0134
0.0134
millinewton
millinewton
per
per
meter
meter
square.
square.
Okay.
Okay.
So
So
now the
now the
area is
area is
given. If
given.
the
If the
area is
area is
given,
given,
we have
we
to
have to
calculate
calculate
what is
what
the
is the
thrust.
thrust.
So the
So the
thrust
thrust
is
is
given
given
as
as
pressure
pressure
into
into
the
the
area,
area,
which is
which is
again
again
to
to
I
I
by
by
C
C
into
into
this.
this.
So
So
we
we
have
have
pressure.
pressure.
This is
This is
pressure
pressure
into
into
area.
area.
Pressure is
Pressure is
given
given
as
as
0.0134,
0.0134,
and
and
the
the
area
area
is
is
18.75
18.75
meter meter
meter
square,
square,
which
which
gives you
gives
a
you a
thrust
thrust
of
of 0.251
Newton.
Newton.
Okay.
Okay.
So
So
any
any
doubts on
doubts on
this?
this?
Okay.
Okay.
Um,
Um.
okay.
Okay.
So
So
if
if
not,
not,
let us
let us
review
review
what
what
all
all
things we
things we
have
have
covered in
covered
this
in this
syllabus.
syllabus.
So we
So we
started with
started with
the
the
orbital
orbital
mechanics
mechanics
part.
part.
So
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 here
here
we have
we have
seen
seen
that
that
we
we
need
need
we need
we need
a
a
velocity
velocity
difference.
difference.
So
So
okay,
okay,
so
so
there are
there are
different type
different
of
type of
missions
missions
that
that
are
are
possible
possible
in a
in a
deep
deep
space.
space.
We can
We can
have a
have a
orbiter
orbiter
mission.
mission.
We can
We can
have
have
a
a
interplanetary
interplanetary
mission.
mission. So
Based on the
based on the
different
different
type of
type of
mission,
mission,
we can
we can
calculate
calculate
what is
what is
the
the
impulse
impulse
that
that
is
is
required
required
by
by
the
the
rocket
rocket
engines.
engines.
Okay,
Okay,
so this is
this is
the
the
delta
delta
V
V
is the
is the
major
major
parameter
parameter
that
that
governs
governs
your
your
uh,
uh,
okay,
okay,
that
that
governs your
governs the
propulsion
propulsion
system
system
that
that
is
is
used
used
to
to
decide
decide
what is
what
the
is the
mass
mass
of
of
propellant that
propellant
is
that is
required and
required
the
and the
type
type
of
of
propulsion
propulsion
system
system
that
that
is
is
required by
required
a
by a
rocket.
rocket.
Okay,
Okay,
so
so
next
next
is
is
okay,
okay.
based on
Based on
this
this,
we
we
calculated
calculated.
so
So
if we
if we
have
have
delta V,
delta V,
you
you
can
can
we can
we can
calc
calc.
so
So
based on
based
the
on the
mission
mission
requirement
requirement,
we
we
have
have
delta
delta
V,
V,
which
which
is
is
fixed by
fixed by
the
the
mission.
mission.
And
And
using
using
delta
delta
V,
V,
we
we
can
can
calculate
calculate
if we
if we
have
have
we can
we can
calculate what
calculate
is the
what is the
mass of the
mass of the
propulsion
propulsion
system
system
that
that
is
is
required.
required.
So
So
this
this
is
is
we
we
can
can
okay, we
okay,
can
we can
use
use
this
this
rocket
rocket
equation, that
equation
is
that is
delta
delta
V
V
is
is
Vj
Vj
ln
ln
uh,
uh,
mb
MB
by
by
okay,
okay,
that
that
is
is
minus
minus
mb
MB
by
by
mu.
MU.
Okay,
Okay,
so
so
if
if
you
you
have
have
this
this
mb is
MB
your
is your
burnout
burnout
mass
mass
and
and
mu is
mu is
the
the
initial
initial
mass.
mass.
So if
So
the
if the
burnout
burnout
mass is
mass
your
is your
structural
structural
mass
mass
plus
plus
the
the
payload
payload
mass,
mass,
and
and
the
the
initial
initial
mass
mass
is
is
the
the
structural
structural
mass
mass
plus
plus
payload
payload
mass
mass
plus
plus
your
your
mass of the
mass of the
propulsion
propulsion
system.
system.
So
So
if you
if you
have a
have a particular
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 mixture
mixture
that
that
the
the
propellants that
propellants
you
that
have
we have
decided,
decided.
so
So
based on
based
that
on
you
that,
can
you can
calculate your
calculate your
vj.
VJ.
uh,
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 okay,
okay,
so
so
yeah,
yeah,
and
and
also
also
it
it
depends on
depends on
your
your
rocket
rocket
engine
engine
design.
design.
So
So
your
your
vj is
VJ is
fixed, you
fixed.
can
You can
calculate what
calculate
is the
what is the
mass of the
mass of the
propellant that
propellant that
is
is
required for
required for
your
your
rocket
rocket
engine.
engine.
Okay,
Okay,
so
so
right,
right.
so
So
next
next
is
is
uh,
uh,
we,
w-
so
so
next
next
thing what
thing
we
what we
have
have
seen
seen
is
is
the
the
detailed
detailed
analysis
analysis
where we
where we
have
have
calculated
calculated
the
the the
area
area
ratio of the
ratio of the
nozzle.
nozzle.
So we
So
have
we have
seen
seen
that
that
a
a
rocket
rocket
engine
engine
looks
looks
is composed
composed
of
of
a
a
combustion
combustion
chamber
chamber
along
along
with
with
a
a
nozzle.
nozzle.
Okay,
Okay,
so
so
so we
so we
need a
need a
CD
CD
nozzle
nozzle
because
because
we
we
want a
want a
supersonic
supersonic
flow
flow
at the
at the
exit.
exit.
and
and
so
so
we
we
have
have
a
a
thrust
thrust
chamber
chamber
which
which
increases
increases
the
your
pressure.
pressure.
So
So
yeah,
yeah,
so
so
based on
based
the
on the
propulsion
propulsion
system
system,
first,
first,
so
so
based on
based
the
on the
structural
structural
limit,
limit,
we
we
design
design
we
we
decide a
decide a
pressure
pressure
limit,
limit,
and
and
we
we
also
also
based on
based on
the
the
mixture
mixture
ratio
ratio
and the
and the
ISP
ISP
profile,
profile,
we
we
have
have
a
a
somewhere
somewhere
local
local
maxima.
maxima. So
So based on
based on
that,
that,
so
so
somewhere
somewhere
near to
near to
this
this
point,
point,
we
we
fix our
fix our
mixture
mixture
ratio.
ratio.
So
So
once the
once the
mixture ratio and
mixturation
pressure is
pressure is
fixed,
fixed,
we
we
can
can
calculate what
calculate
is
what
the
is the
chamber
chamber
temperature.
temperature.
And
And
so
so
once the
once the
chamber
chamber
temperature
temperature
is
is
fixed,
fixed,
we can
we can
calculate what
calculate
is
what is
the
the
T
T
exit.
exit.
We can
We can
calculate
calculate
based on
based
the
on the
thrust.
thrust.
We can
We can
calculate
calculate
our
our
area
area
ratio
ratio
and
and
our
our
mass flow
mass flow
rate.
rate.
Okay,
Okay.
so
So
and
and
also
also
since we
since
know
we
our
know our
temperature
temperature
T
T
naught,
naught,
we can
we can
calculate
calculate
what
what
is
is
how the
how the
temperature will
temperature will
vary
vary
along
along
this
this
nozzle,
nozzle,
if we
if
know
we
the
know the
contour of
contour
the
of the
nozzle.
nozzle.
And
And
once we
once we
have a
have a
contour, we
contour, we
can
can
basically
basically
design
design
a
a
cooling
cooling
system
system
also
also
for
for
this
this
rocket
rocket
engine.
engine.
Okay,
Okay.
so
So
yeah,
yeah.
so
So this is the
this is
this is
how a
how a
thrust
thrust
chamber is
chamber is
calculated.
calculated.
Um,
Um,
okay,
okay.
so
So so
next
next
part
part
was
was
we can
we can
also
also
have
have
a
a
solid
solid
rocket
rocket
motor,
motor,
or we
or we
can
can
have
have
a
a
liquid
liquid
rocket
rocket
engine
engine
based
based
on
on
our
our
requirement.
requirement.
So
So
we
so
have
we have
seen
seen
how
how a
a CD how
how
a
a
CD
CD
nozzle
nozzle
was
was
designed.
designed.
So
So
okay,
okay.
so
So
yeah,
yeah.
so
So
we
we
did the
did the
combustion
combustion
calculations. We
calculations.
have
We have
seen
seen
that the
that the
ISP ISP
ISP
varies with the
varies with the
mixture
mixture
ratio,
ratio,
and
and
we
we
choose
choose
our
our
mixture
mixture
ratio
ratio
somewhere
somewhere uh,
where the
where the
mixture
mixture
ratio is
ratio is
maximum,
maximum,
the specific
specific
impulse is
impulse is
maximum.
maximum.
Okay,
Okay,
and
and
yeah, so next
next
was
was
we have
we
seen
have
how
seen how
the
the
adiabatic
adiabatic
temperature
temperature
calculation is
calculation is
done.
done.
So
So
okay,
okay.
so
So
and in
and
real
in real
life
life,
how it
how
is
it
done
is done
using a
using a
gas-free
gas-free
energy
energy
calculation.
calculation.
And
And
we have
we have
seen how
seen
a
how a
liquid
liquid
solid
solid
rocket
rocket
engine is
engine is
designed,
designed,
and
and
later we
later
have
we have
seen how
seen how
different
different
type
type
of
of
cycles are
cycles are
used in
used in
liquid
liquid
rocket
rocket
engines,
engines,
like
like
gas
gas
generator
generator
cycle,
cycle,
stage
stage
combustion
combustion
cycle, and the
cycle, and the
expander
expander
cycle.
cycle.
So
So
the
the
stage
stage
combustion
combustion
cycle is
cycle is
used
used
when
when we have
we don't
we
have a
don't have a
limitation for
limitation for
the
the
chamber
chamber
pressure.
pressure.
So it is
So it
used
is
for a
used for
higher
a higher
chamber
chamber
pressures.
pressures.
And the
And the
expander
expander
cycle is
cycle is
used
used
when
when
we can
we can
use
use
the
the
benefit
benefit
of
of
the
the
cryogenic cryogenic
cryogenic
engines.
engines.
Okay,
Okay,
so
so
yeah,
yeah,
so
so
we have
we have
seen
seen
so
so
later we
later
have
we have
seen
seen
in
in
the
the
situation
situation
that
that
the
the
rocket
rocket
engine
engine
requires
requires
cooling
cooling
system.
system.
So it
So
can
it can
be
be
film
film
cooling, it
cooling, it
can
can
be
be
the
the
transpiration
transpiration
cooling, it
cooling, it
can
can
be
be
the
abrasive
ablated
ablated
cooling
cooling
system.
system.
So
So
yeah,
yeah,
so
so so
later
later
we have
we have
seen
seen
the
the
liquid
liquid
rocket
rocket
sometimes
sometimes
may
may
become
become
unstable.
unstable.
So
So
that is
that is
because
because
of
of uh,
combustion
combustion
instability
instability
that
that
occurs
occurs
inside a
inside a
liquid
liquid
rocket
rocket
engine.
engine.
So
So
yeah,
yeah,
okay,
okay.
so
So
then
then
at the
and the
later
later
stage
stage,
we have
we have
seen
seen
the
the
different type
different
of
type of
other
other
rocket
rocket
engines,
engines,
such
such
as
as
the
the
hybrid rocket
hybrid rocket
engine, which
engine, which
uses
uses
the
the
benefit
benefit
of
of
yeah,
yeah,
uses the
uses the
benefit
benefit
of
of
solid
solid
rocket as
rocket
well
as
as
well
the
as the
liquid
liquid
rockets.
rockets.
Uh,
Uh,
then
then
we have
we have
seen
seen
the different
the
type of
different type of
rocket
rocket
engines, like
engine, like
electric
electric
propulsion
propulsion
system,
system,
the
the
nuclear
nuclear
propulsion
propulsion
system,
system,
and
and
the
the
solar
solar
sail.
sail.
Okay,
Okay,
so
so
okay,
okay,
so with
so with
this
this
If you
If
have
you
any
have any
doubt, please
doubt,
let
please
me
let
know.
me know.
Is there
Is
any
there
doubt,
any doubt,
Padmavati?
Padmavati?
Okay.
Okay.
So
So
if
if
not,
not,
so
so
we'll
we'll
close the
close the
session
session
because
because
so
so
most of,
most
this was
this
the
was the
last
last
tutorial,
tutorial,
and
and
so only
so only
solar
solar
say
say
the
the
electric
electric
propulsion
propulsion
was
was
covered.
covered.
So
So
yeah, if
yeah,
you
if
don't
you
have
don't
any
have any
doubt,
doubt,
we'll
we'll
close the
close the
session.
session.
Okay.
Okay.
Okay. Yeah.
Okay.
Thank you.
Thank you.
Thank you for
Thank you for
joining.
joining.